Hey, it's Tom, and today we're going to talk about probably the most popular collection type in Swift and probably in all other programming languages. Today we're going to talk about arrays. So let's jump to the code. Okay, so we are now in the playground and we can start with creating an array. So to create an array, we can of course just declare it using Swift type annotation syntax. So we can do something like this. String array, and that will be array of elements of type string. Like any other collection type in Swift, arrays are strongly typed, so it can contain only objects of the same type. So whole collection, like whole array, will contain only objects of type declared while creating this array. In this case, it will be collection of strings. Of course, arrays, like in any other languages, are ordered collections. So that's a good use case when you need a collection with knowledge about in which particular order the elements were added to the collection. And that's definitely the use case for use arrays. One of the use cases might be a shopping cart in which users just want to know the order in which products were added to the cart. And the other very popular use case is creating queues like the first in, first out, or last in, first out. And Swift syntax supports that by append or remove last methods. But we'll just go to that a little bit later. Okay, so when we are in create, we can use two types of initialization arrays. So the first type is using the initializer syntax, like also in any other collections. So let's maybe create a mutable array of ints. Int array, and that will be array of int, and it's now already created because Swift is using type inference, so we don't have to declare that the int array is a collection of type int. But while we are creating that using the initializer syntax, the type inference allows Swift compiler to know that the int array is a variable which contains an array of objects of type int. And there is a shorter type, so let maybe shortest int array. It's something like this. It's very similar to the array literal form of creating the array, but still it uses the initializer syntax. And as in case of any other variables in Swift, the first one using the var keyword is mutable, and the second one created using the let keyword is immutable. So both the content and the size of this array cannot be changed in future. So in this case, we just have an empty array and we cannot add anything to this array. Okay, so as I mentioned a little bit earlier, we can also use the array literal form of creating the array. So let's maybe create literal int array, and the syntax is pretty simple. That's it. We just created an empty array of int objects. However, this is not the most popular way to create an arrays. The most popular I see in many cases is just initialize an array with some predefined values taken from other collection or just defined on the go. So let's create maybe let immutable iPhones. Why not? And that will be array of new iPhones. pro max. Okay, so that's probably the most common way to initialize arrays in Swift, and the one you will probably see in many cases. We just created an immutable collection of iPhones, and by using the inference mechanism, Swift compiler knows that it's the array of string objects, and that's it. It's already working, and that's pretty self-describing solution. Okay, so maybe also create mutable version, so we can work with that a little bit later. Maybe call it just iPhones. It will be just shorter, and we can use the same array literal syntax, and we have collection called iPhones. Of course, like in case of any other collection in Swift, there are some shortcuts and available methods to just check the count of the collection, or to just verify if it's empty. And as we see, yeah, there are 3 elements, so it's not empty, definitely, it's false. Okay, so maybe let's switch into modifying content of the collection. So at first we can add elements, maybe modify. We can add elements to the collection, and there are 2 ways to do it. So iPhones append, we can add just one element. For example, it might be XR, but we can also add an elements from new sequence. So for example, new array, and we can define the array on the go. So maybe let's add iPhone 8 and 8 Plus. Yeah, so right now we can print the array. And yeah, as you see, it's ordered, as I mentioned. So the order in which we added elements is very important. And using append method, we are just adding an element to the end of the collection. Of course, sometimes we may need to add this element at some particular place. So in this case, we could use the insert method. iPhones insert. For example, if we want to add an element to the beginning of the array, we can add it at index 0 and print iPhones should show us the iPhone 7 at the first place. Yeah, it's at the first place. That's working. That's good news. Now it's time to remove elements. So as I mentioned before, arrays in Swift are a very convenient way to create some queues, like the first in, first out, or last in, first out. And there are a couple methods to support that. So definitely adding elements to the end is supported by append method. But we have also a couple methods which are enabling us remove elements. So we can iPhones remove first. That will be convenient while using the first in, first out queue. We can remove last. So that's a very convenient method to implement the last in, first out queue. And we can, of course, remove element at some particular index. So in this case, it might be 0. Yeah, it's working. And as you see, all those methods return the element which is being removed from array. So that's why it's a very convenient way to implement some kind of queues. Yeah, so right now we removed a couple elements, so we can just keep it as this. So we have whole collection, yeah, of iPhones. And of course, we can just update elements of collection. So we can just use subscription to a particular index. However, I I strongly believe it's not very supported by Apple. They don't want you to access the elements of an array directly. But we'll go to that a little bit later while iterating through the array. So we can replace the iPhone 11 with 5S. Yeah, that was really good phone. And it's still working. Okay, yeah, as you see, the first element was replaced. Okay, so we have update. And now it's probably time to sort the elements of array. So as long as the elements of array conform to comparable protocol, we can just call the sorted method, sorry. So let's sorted iPhones equals to iPhones sorted, and so as long as all elements conform to comparable protocol, we don't have to implement any compare method. So the good thing is also that all basic types already support comparable protocol. So just strings, numbers, booleans. That's the good thing. And as you see, they are sorted because they are strings. So yeah, they're being sorted. Oh, sorry, my bad. Something was wrong, and I noticed that, yeah, right now they are sorted. So the numbers are first, and then the characters like XR. Okay, so we already sorted the array, and like any collection types in the standard library, arrays have value semantics. So if we assign an array to a different variable, we are assigning a copy. So if we assign, yeah, let maybe show that. So our iPhones copy, iPhones. So iPhone's copy is now a copy of the array, which was stored in iPhone's variable. So we can mutate that, we can change that. iPhone's copy, for example, remove last element. And now we can print iPhone's copy and print iPhones. And as you will notice, yeah, we removed element only from iPhone's copy, because of the value semantics, the iPhone's copy is a copy of the array which was stored in iPhones, and as long as those elements are being referenced by value, we can just change them. If they are objects of classes, it's working in a different way. And the same works also in methods. So if we put an array as a parameter to a method, it's also using the value semantics. So the method is using copy of an array, not the same array that was put as a parameter. Okay, so now maybe it's time to access elements. So as I mentioned before, we can access elements using the index subscription. So, for example, let first iPhone to be the iPhones of index 0. But there are a couple more convenient methods. So, for example, first iPhone might be accessed by iPhones first, and that's a very safe method, because if there is no element, it's just returning nil. The same thing works with the last version. Last iPhone is iPhones last. And as you see, it's also optional, so if the array will be empty, there will be just nil, nothing will be broken. So both those methods are safe to use. And yeah, now it's time to iterate through the collection. So as I mentioned before, Apple is probably not a big fan of iterating using indexes. So they provided a couple different methods to iterate through the elements, but with hiding the index itself usually. So the most simple for loop is just an element, so iPhone in iPhones. And we can, of course, print this iPhone. That's the very basic version of the for loop. The other version is that we can add drop last or drop first. And in this case, when we drop last, we iterate through all elements except the last one. And there's also a version in which we can drop first. And first, yeah. And in this case, we iterate over all elements except the first one. Of course, in some cases, we may need to access an index of an object because that might be important in case of our logic. So there is also a version in which we have an index element in iPhones enumerated. Yeah, and in this case, when we enumerate through the collection, we have an access to both an index and element. So we can, for example, print index, and we can also print element iPhone. Yeah, so maybe let's just comment that out. And yeah, as you see, we have both indexes and objects. Okay, we can comment that out because we already iterated through the whole collection. And of course, we can check for some element in the collection. However, that's honestly an anti-pattern, because when you are checking the existence of element in array collection, the time complexity is O of n. So it's growing linearly according to the size of the array. So the bigger is the array, the time to check will grow, and at worst case might be n times longer than in case of the shorter array. If you just need to verify if the element is in the collection, much better choice might be a set, or even a dictionary will be much better. Okay, so but still, at some point we might need to find an element. So let first index first, maybe not new iPhone, and we'll call iPhones first index of string, and first index, yeah, where, and there's an iPhone, it's returning boolean, and return iPhone contains 11. If it's not 11, then it's probably not new. Yeah, it's not new. And right now we can print this element. First not new index, first not new iPhone. It's an index, so it's optional. The index is free, so 0, 1, 2, 3 XR. That's working. Okay. Now we already found element, and of course, like in case of any other collection in Swift, we can also use map, filter, reduce, to make functional changes and transformations on the arrays. So maybe let uppercase iPhones, it will be just simple iPhones map, and we can use the shorter form, so $0 uppercase. Yeah, so print uppercase iPhones. Yeah, so we are just going through the all elements and transforming that using the uppercase method, which is provided by Foundation in Swift. We can also, of course, filter elements. So only new iPhones. Yeah, that should work. And iPhones filter. Yeah, so we can use the longer version and return iPhone contains 11 and print only new iPhones. Yeah, so it's working. Of course, we can change the results, but you can do that with any other collection type. Okay, so we just went through all aspects of arrays in Swift. I hope you enjoyed the video. If you have any questions, feel free to ask me in the comments section. I will be more than happy to help you. And thank you for your time. See you next time. Bye.